let's talk about the lag screw and neutralization plate. Like we reviewed in the previous video, lag screws work best in simple oblique fractures, spiral fractures, and selected partial articular fractures where you can achieve anatomic reduction and compress the main fragments together. So, the second way to create the lag effect is by screw design. A partially threaded screw can generate compression as long as the threaded portion lies completely beyond the fracture line, inside the far fragment, and does not engage the near fragment. Why does that work? Because the smooth part of the screw, the shank, acts as the gliding segment. So unlike a fully threaded screw, you often do not need to drill a separate gliding hole. But there is one non-negotiable rule. All the threads must be in the far fragment. If even part of the threaded section remains in the near fragment, the screw grips both sides, and instead of gliding and compressing, it just holds both fragments. That means you lose the lag effect. This technique is especially common in cancellous or metaphyseal bone. In that setting, AO notes that the screw often does not need to penetrate the far cortex because the threads are designed to hold in cancellous bone. Also, because metaphyseal cortex is thin, a washer is often useful to prevent the screw head from sinking into bone. And here is a very important teaching point. Compression is not the same as full stability. A lag screw can compress two fragments together, but that does not automatically mean the construct can resist bending, torsion, and shear well enough on its own. An unprotected lag screws may fail under those forces, especially with repetitive or excessive loading. That is why a neutralization plate, also called a protection plate, is often added to protect the lag screw construct while the fracture heals. The plate is applied with screws in neutral mode, so its job is not to add more compression, but to protect the compression already created by the lag screw. To do this effectively, the plate needs sufficient fixation on each main fragment, classically about 3 bicortical screws per side, so the construct can truly share load and resist deformation. Biomechanically, the plate acts like an external beam, helping share load across the entire spanning construct. That said, the 3 bicortical screws per side rule is just a guideline. However, fewer screws may be acceptable in some locking constructs or specific bones, but for simple diaphyseal patterns under rotational stress, it remains the safest and most reproducible principle.